this group, we're going to present our function and partial derivative discussion. And before we start, let us introduce ourselves. Start from me. My name is Liani. I'm from International Management class with new B 1024-22-1007. Okay, so the first is definition. Function derivative is a calculation of change in function values due to change in input values or variables. The derivative of function, or f(x), represents its rate of change, and it is denoted by either f(x) in parentheses x or delta f per delta x. So function derivative written as f(x) in parentheses x equal to limit h approach 0 f open parentheses x plus h close parentheses minus f parentheses x and per h. And as we can see in the figure, delta x that you can see in the right, delta x represents a change in value of x. And we keep making this interval between x and x plus delta x smaller until it is infinite small. Hence, we have the limit delta x approach 0, and at here it's written as h approach 0. And the numerator, that is f open parentheses x plus delta x minus f open parentheses and x, represent the correspondence change in the value of the function f over the interval delta x. And as we can see, to calculate the change in function, all of the function, it's hard to use this function derivative definition. So at function derivative, there's a rules, and there are 9 general rules. That the first one is derivative of a constant function. That is, the formula is delta y per delta x equals 0. That means every kind of function that only consists of a constant, whether it's 1 million or 100, that's going to get 0. And the second one is derivative of a power function. If y equal x to the power of n, and if n at here is a positive integer, then the formula is delta y per delta x is equal to n times x to the power of n minus 1. And the third one, derivative of a constant multiple and power. At here, our function consists of one constant, and then there's a function 2. So if y equal key times by phi, and phi is a function that is h open parenthesis x and close parenthesis, then the formula is delta y per delta x is equal to key times by delta v per delta x. Fourth one is derivative of a constant division and power. And here, if y equal k per v, then the formula is delta y per delta x equal to k times by delta v per delta x per v to the power of 2. And the fifth one is derivative of a sum and difference rules. If y equal to u plus or minus phi, where u is a function that is g open parenthesis x, and phi is a function too that is h open parenthesis x and close parenthesis, then the formula is delta y per delta x equal to delta u per delta x plus or minus delta v per delta x. And the sixth one is derivative of multiple function. And here the function is y equal u times with a phi, where u is a function that is g open parenthesis x close parenthesis, and phi is h open parenthesis and x close parenthesis. Then the formula is delta y per delta x equal to u times by delta phi per delta x plus phi times by delta phi or delta x. Or we can simplify it as u times by phi xn plus phi times by u xn. The seventh one is derivative of quotient function. And here if y equal to u per v, where u is g open parenthesis x and phi open parenthesis h open parenthesis close parenthesis, then the formula is delta y per delta x equal to phi times with u xn minus u times phi xn per phi to the power of 2 or phi squared. The eighth one is derivative of composite function. And here if y equal f open parenthesis x close parenthesis, where u equal g open parenthesis x close parenthesis, then the formula is delta y per delta x equal delta y per delta u times with delta u per delta x. And the last one is derivative of powered function. And here if the function is u to the power of n, where u equal g the open parenthesis x and close parenthesis, and n at here is a constant, then the formula of this derivative is delta y per delta x equal n times with u times with n minus 1 times with delta u per delta x.
Hello, my name is Marleny F with student ID number B1024221006. Okay, now I will explain derivative rule. Number 1, derivative of a constant function dy per dx equals 0. When f of x equals c is a constant, so first derivative of x is equal 0. It means whatever the constant or c, the derivative will be 0. Example, the function is 3, and then first derivative will be 0. How to the proof? The proving is when first derivative equal limit h to 0, and then the definition of derivative, f of x plus h minus f of x per h equal limit h to 0. The x plus h is 3 minus fx is 3 per h, and then the limit h to 0, 3 minus 3 per h is 0, and then the first derivative of 3 is 0. And then number 2, derivative of a power function. If y equal x to the n power, and if n is a positive integer, then dy per dx equal nx to the n minus 1 power. It means reducing the power with the formula n minus 1 to get the first derivative. Y is initial function, and then y prime is the first derivative of the y function. Example that I made, y equal x to the 5th power. The first derivative is the n is 5 from the power of x, 5, and then 5x to the 5th power minus 1 equal 5x to the 4th power. And then this is the proof. Okay, and then number 3, derivative of a constant multiple and power. If y equal kv and v equal h of x, then dy per dx equal k dv per dx. It means multiply the constant with the n and reducing the power with the formula n minus 1 to get the first derivative. Example that I made, y equal 4x to the 4th power. The first derivative equal 4. 4 is from the x power is 4, and then 4x, and then to the 4th power minus 1 equal 4x to the 3rd power, and then 4 multiplied with 4 is 16x to the 3rd power. Okay, now I will explain about derivative rules, meaning, and example. Number 4, derivative of a constant division and power. If y equal k per v prime, then the formula will appear is dy per dx equal k dv per dx per v with 2 power. It means we have to solve the v with 2 power with the formula x the power of n, and then multiply by 2, or we can say it multiply the power of x with 2, and we have to multiply the constant with the dv per dx that we already solved to get the first derivative. There is example that I made. The function is y equal 5 per x with 4 power. So dv per dx equal 4x. 4 is from the power of x is 4. We type it 4x 4 minus 1 because the power of x we have to reduce it by 1. So 4 minus 1 is 3. So equal 4x with 3 power. And then we have to solve the v2. The v2 equal x with 4 power multiply by 2 equal x with 8 power. And then the formula dy per dx equal k dv per dx per v with 2 power equal the k is 5. Okay, we type 5, and then we multiply by 4x3. There is dv per dx 4x with 3 power, and then per v2 is x with 8 power. And then the first derivative for this function, for the function of y equal 5 per x with 4 power is 20 x with 3 power per x with 8 power. Okay, next next number 5, derivative of a sum and difference rules. If y equal u plus v, where u equal g of x and v equal h of x, then the formula will appear is dy per dx equal du per dx plus dv per dx. The meaning of this rule is, it means we have to solve the u and v, then we compute both to be the first derivative, And then we have to reducing the number of power happened in dv per dx with the formula and x the power of n minus 1. Okay, there is the example that I made. The function is y equal 6x with 2 power plus x with 5 power. And then we have to solve the u equal 6x with 2 power. So du per dx equal 6 multiply with 2 from the power of x, so 12, and then the power of x is 2, we reduce it with 1, so 2 minus 1 is 1. We don't have to write it again because without we write it, it means 1. So equal 12x, and then we have to solve the v. The v is x5, so dv per dx equal 5. 5 is n. We have to remember the formula is dv per dx equal nx, and then the power of n minus 1. So the n is from the power is 5. Okay, we type 5, and then we 5x, we have to reduce the power of x. 5 minus 1 is 4, so dv per dx equal 5x with 4 power. And then the formula dy per dx equal du per dx plus dv per dx equal 12x plus 5x with 4 power. So the first derivative is 12x plus 5x with 4 power. Okay, now I will explain about derivatives of multiple function. If y equal uv, where u equal g of x and v equal h of x, then the formula will appear is dy per dx equal u dv per dx plus v dv per dx, or dy per dx equal u prime v plus uv prime. It means we have to know the first derivative from u and v, then we can solve the first derivative of the function with schema multiplication. We use multiple function if the function that we want to solve are two function multiplying. So there is the example that I made. The function is y equal x plus 1, x plus 2, x plus 2 to the 4th power. Okay, we have to solve the u first. U equal x plus 1, so the derivative of u equal 1. And then we have to solve the v. V equal x plus 2 to the 4th power. The derivative equal 4 is n, so we type 4, and then 4x plus 2, and then the 4th power we reduce 1, so will be 3. It means the derivative of v equal 4x plus 2 to the 3rd power. And then the formula, I'm using the second formulas. Y equal u prime v plus uv prime. So y prime equal 1 is from u is from derivative of u, and then x plus 2 with 4 power is from the v, and then plus the u is x plus 1, and then the v derivative are 4, x plus 2 to the 3rd power equal, we using schema multiplication, 1 equal x plus 2 to the fourth power is x plus 2 to the fourth power plus we move the 4 to the front of x plus 1, so 4 multiply with x is 4x, and then 4 multiply with 1 is plus 4 I mean, and then the x plus 2 to the third power, still x plus 2 to the third power. So the first derivative of this function is x plus 2 to the fourth power plus 4x plus 4, and then x plus 2 to the third power is the first derivative of this function. Next, number 7, derivative of quotient function. If y equal u per v, where u equal g of x and v equal h of x, then dy per dx equal u prime v minus v prime u per v to the second power. The meaning of this derivative rule is this function will be used if the function is quotient or fraction, and the function that want to be solved must be two function. We have to solve the first derivative of u and v for solve the first derivative function. There is example that I made. The f of x equal x to the second power plus 7 per x to the second power minus 3. We have to solve the u first. U equal x to the second power plus 7. So u prime equal to x. Okay. And then v, we have to solve the v. V equal x to the second power minus 3 equal to x. We have to remember the formula is dy per dx equal u prime v minus v prime u per v to the second power. And then the derivative of u is 2x. We type 2x in here, and then the v is x to the second power minus 3, and then minus derivative of v is 2x, and then we type the u is x to the second power plus 7 per x to the second 2 power minus 3, and then v2 is to the second power, and then equal 2x to the third power minus 6x. We use schema multiplication. Okay. 2x multiplied with x to the second power is 2x to the third power, and then 2x we multiply by 3 is minus 6x, and then minus we multiplication again, 2x multiplied by x to the second power is 2x to the third power plus 2x multiplied by 7 is plus 14x per x to the second power minus 3, and then multiply by to the second power, and then equal 2x to the third power minus 6x minus 2x to the third power, and then we have to change the plus symbol with minus, and then minus 14x, and then per x to the second power minus 3, and then to the second power. And then the first derivative for this function is minus 20x per x to the second power minus 3, and then to the second power. Okay, next I will explain derivative rule number 8, derivative of composite function. If y equal f of x, where u equal g of x, then the formula will appear is dy per dx equal dy per du times by du per dx. There is example that I made. The function is y equal 3x plus 4 to the second power, and then dy per dx equal the n is from the power, second power, so we type 2 in front of 3x plus 4, and then x in 3x, we reduce the power with 1, and then 1 minus 1 is 0, so we don't have to type again, so we type 2 3x plus 4 multiply by 3 and then equal, we use schema multiplication again, 2 multiply with 3x equal 6x, and then 6x we multiply with 3 is 18x, and then plus 4, and then plus 24. Why 24? It is because 2 multiply with 4 is 8, and then 8 multiply by 3. It means 24. So the first derivative for this function is 18x plus 24.
The first exercise of function derivative. Find the first derivative of f open parenthesis x close parenthesis equal 4x squared plus 3 per 2x minus 2. And at here we use the derivative quotient rules. That is fx in open parenthesis x close parenthesis equal to phi times with u x in minus u times with phi x in per phi squared. And at here, the u is 4x squared plus 3, and the phi is 2x minus 2. So before we use it to the formula, we need to differentiate it first. So the u, that is 4x squared plus 3, we derivative it, so we got u accent is equal 8x. At here, why is this 8? Because the 4 at the front, we times it with 2, so we got 8, and the x squared, we minus it with 1, so we got x. And for the 3 is already gone because we use the derivative rules, that is every constant will going to be 0 in the first derivative. And for the phi accent is equal to 2 because the 2 we times it with 1 from the x power, and then the x we minus it with 1, so it is gone. And we substitute all of this to the formula. So we got open parenthesis 2x minus 2 close parenthesis times with 8x minus open parenthesis 4x squared plus 3 close parenthesis 2 per open parenthesis 2x minus 2 close parenthesis squared. And then after that we multiply all of this, so we got 16x squared minus 16x minus open parenthesis 8x squared plus 6 close parenthesis per open parenthesis 2x minus 2 close parenthesis squared. And the final, we got the answer that is 8x squared minus 16x per open parenthesis 2x minus 2 close parenthesis squared. And exercise number 2 is a home garden project can be finished in X day with cost open parenthesis 4x minus 240 plus 10,000 per x close parenthesis in 1,000 rupiahs per days. How much the minimum cost need to pay to finish the project? And the answer, we need to find the total cost first. So we'll write it as C open parenthesis X close parenthesis equal to, we need to times the cost with the days. So at here, X open parenthesis for X minus 240 plus 10,000 per X close parenthesis. And then we multiply it, the X with all of the costs. So we got 4x squared minus 240x plus 10,000. And at here, because we want to find the x, so we need to make the cx is going to be 0. So we derivative it, the 4x squared minus 240x. So we got 8x minus 240 equal to 0. And we got the x is 30 days. And then this 30, we need to substitute it to our first formula. That is 4 open parenthesis 30 close parenthesis to the power of 2 minus 240 times with 30 plus 10,000. And then we'll multiply. So we got 360 minus 7,200 plus 10,000. So we got 3,160. And because at here it is say in 1,000 rupiahs, so we need to time this 3,160 with 1,000 rupiahs. So the minimum cost that need to pay to finish the project is 3,160,000 rupiahs.
Okay, now I will explain about partial derivatives. So there is a question about partial derivatives. Okay, now z equal x2 y3. Okay, first we have to type derivative of x. Okay, equal when we solve the derivative of x, the y will be a constant. Okay, so first the power of x is 2, so we type 2 x, and then the power of 2 is reduced with 1, so 2 minus 1 is 1. We don't have to write it, so the y will be constant. Okay, yeah, like that. Okay, done with the first derivative of x, and then we have to type again, and then we have to type again dou z per dou y equal when we have when we want to solve the derivative of y, so the x will be constant. We type again x with 2 power, and then the power in y is 3, right? It's 3. We type 3 in here, and then y, and 3 minus 1 is 2. Okay, done. So the partial derivatives of z equal x2 and y3 is 2xy3 and 3x2 y2.
Hi, I'm Dameria A with NIM B1024221008. Now I will explain this example exercise for derivative of the function. Now the question is, find the first derivative of the function f open bracket x close bracket equal to 3x the power of 4. The answer is f open bracket x close bracket equal to 4 multiplication 3 x the power of 4 mean 1. Now the answer is f open bracket x close bracket equal to 12 from 4 multiplication 3 and x is the power of 3 from 4 mean 1. So the first derivation of the function f open bracket x equal to 3 x for the power of 4 is f open bracket x close bracket equal to 12x the power of 3.
Next, I will explain about examples of derivatives of function. The question is, find the first derivatives of the function f parenthesis x equal 15x. So the answer is f parenthesis x equal 15x. F accent parenthesis x equal 15x1. F accent parenthesis x equal 15x1 minus 1. F accent parenthesis x equal 15x0. F accent parenthesis x equal 15. So the first derivative of the function f parenthesis x equal 15x is f accent parenthesis x equal 15.
Hi everyone, still I'm Dameria A with NIM B1024221008. Now I will explain the partial derivative. So what the partial derivative is? A partial derivative can be defined as a derivative in which some variable are kept constant and the derivative of a function with respect to the other variable can be determined. And the process of calculating partial derivative is the same as that of an ordinary derivative, except we consider the other variables than the variable with respect to which we are differentiating as a constant. So the partial derivative of a multivariable function, say z with notative z equal to f open bracket x it v comma y close bracket is its derivative with respect to one of the variable x or y. In this case, where the other variable are treated are constant. For example, for finding the partial derivative of f open bracket x comma y close bracket with respect to x, which is represented by del f or with respect del x close bracket. Y is treated as a constant. And for finding the partial derivative of f, open bracket x, comma y, close bracket, with respect to y, which is represented by del f per respect del y, and x is treated as constant. And note that we are not consider all the variable as variable while doing partial differentiation. Instead, we are considering only one variable as a variable at a time. And hence, and the name partial, the limit definition of partial derivative looks very similar to the limit definition of the derivative. We can find the partial derivative using the following limit formula if you want. So the partial derivative of the f with respect to x. As you can see, there is the formula of the limit following limit formula. So we are going to the next explanation, the total differential. So given a function of two or the total differential is given a function of two or more independent variable where all the independent variables are assumed to be independent of each other, so that it can vary by itself without affecting the others. The total differential measures the total change in the dependent variable due change in all independent variable. So we can see the function in there, z equal to f, open bracket x, comma y. So where x and y are assumed to be independent of each other, the total change in z denoted by del z due to the change in variable x and y is the del z. So the formula del z equal to fx multiplication del x plus fy multiplication del y. Or we can use del z equal to del z per del x per Spain and multiplication del x plus del z per del y equal multiplication del y. So that's all from me. So next the Alensia will explain.
Next, I will explain about example of partial derivatives. The question is, find the first derivative of z equal x plus y by x minus y. So the answer is dou z by dou x equal 1 times parenthesis x minus y minus parenthesis x plus y times 1 by parenthesis x minus y to the power of 2 equal minus 2y by parenthesis x minus y to the power of 2. Next, do z by do y equal 1 times parenthesis x minus y minus parenthesis x plus y times parenthesis minus 1 by parenthesis x minus y to the power of 2 equal to x by parenthesis x minus y to the power of 2. Next, I will explain about example of total differential. The question is, calculate the total differential of the function on f parenthesis x point y equal x the power of 2 plus 3xy the power of 2 minus 5y the power of 3. So the answer is fz parenthesis x point y equal 2x plus 3y the power of 2 and fy parenthesis x point y equal 6xy minus 15y the power of 2. So the total derivative is dy equal 2x plus 3y the power of 2 plus 6xy minus 15y the power of 2. Hello everyone, my name is Alensia Anjelika. I'm from International Class Management Study Program. So here I will explain about implicit function. An implicit function is a function that contains more than one variable. The types of independent variables and dependent variables are in one side, so that they cannot be separated on different sides. Next, I will explain about example of implicit function. The question is, find the dy by dx of x the power of 3 plus y the power of 3 minus 9xy equals 0. So, the answer is d by dx parenthesis x the power of 3 plus y the power of 3 minus 9xy equal d by dx parenthesis 0. 3x the power of 2 plus 3y the power of 2 times dy by dx minus 9 parenthesis y plus x dy by dx equals 0. 3x the power of 2 plus 3y the power of 2 dy by dx minus 9y minus x dy by dx equals 0. 3y the power of 2 dy by dx minus x dy by dx equal 9y minus 3x the power of 2. dy by dx parenthesis 3y the power of 2 minus x equal 9y minus 3y the power of 2. So, dy by dx equal 9y minus 3x the power of 2 by 3y the power of 2 minus x. So, hasil dari dy by dx dari x the power of 3 plus y the power of 3 minus 9xy equals 0 is dy by dx equal 9y minus 3x the power of 2 by 3y the power of 2 minus x.
The first exercise of first partial derivative. Find the first partial derivative fx for f open parenthesis x comma y close parenthesis equal 2x plus y per x minus y. And the answer, because this is a rational, so we use derivative quotient rules. That is phi times with u accent minus u times with phi accent per phi squared. And at here, the u is 2x plus y and the phi is x minus y. So we need to find the first partial derivative first. So the u accent is 2 because, as we can see, 2x, so the 1, because the x is only have power 1, so we times the 2 with 1, so we got 2, and the x we minus it with 1, so it's gone. And here we consider the y as a constant because this we find it the first partial derivative only for fx. So the phi accent is 1 because it's the same. We consider the y as a constant, and here the coefficient is 1, so we times 1 with 1. And then we use And then we substitute all of this to the formula, that is 2 open parenthesis x minus y close parenthesis minus open parenthesis 2x plus y close parenthesis times 1 per open parenthesis x minus y close parenthesis squared. And then we multiply all of this, so we got 2x minus 2y minus 2x minus y per open parenthesis x minus y close parenthesis to the power of 2. And because at here 2x minus 2x, that's equals 0, so we only got minus 3y per open parenthesis x minus y close parenthesis to the power of 2.
Hi, I'm Dameria A with NIM B1024221008. Now I will explain the example exercise for partial derivative. So the question is, find the partial derivative of the function z equal to x the power of 4 y the power of 2. So the solution is, because we trying to find the del, so del z equal del x respect, so equal to 4, because we use del x, so the y becomes constant. So we going to put the power of x first, so 4x the power of 3 y the power of 2. Now we going to do the opposite, del z per respect to del y equal to, because del y, so the x become constant now, so the power is going to stay on there, x4. No, so we are going to put the power of y first, 2 x the power of 4 y. So that's all. Now we are going to move to the next example exercise. So the next example exercise is z equal to 4x the power of 3 plus 8x the power of 2 y the power of 2 plus 6 y the power of 2. The solution is that del z per respect del x equal to 12x the power of 2 from 4 multiplication from the power 3. So plus 16 from 8 6 the power 2 y the power of 2. We are not going to put 6 y the power of 2 because see that variable doesn't have x, that number doesn't have x variable, so we are not going to put there. So we're going to move to the del the power of 2 z respect to del x quadrant 2 equal to 24x from 12 multiplication from with the power of 2 plus, so because it are the multiplication, so it doesn't have quadrant anymore, so plus 16 multiplication y the power of 2. Now del the power of 2 z respect to the del x respect to del y equal to 32x multiplication y, because the 12 doesn't have y variable y, so we are just going to use the 16. So that's all. Now we are going to find the del y also. So the del z del z respect to del y equal to 16 x the power of 2 multiplication y plus 12 y, because we are not going to put the 4 because 4 doesn't have y in there. So after that, del quadrat 2 the power of 2 z per del y respect del y the power of 2 equal to 16 x the power of 2 plus 12 del the power of 2 z per del y respect del x equal to 32x the multiplication y. So the result from the mixed del is going to be same. So that's all from me.
Okay, now I will explain about partial derivatives. So there is a question about partial derivatives. Okay, now z equal x2 y3. Okay, um, first we have to type derivative of x. Okay, equal when we solve the derivative of x, the y will be a constant. Okay, so first the power of x is 2, so we type 2 x, and then the power of 2 is reduced with 1, so 2 minus 1 is 1. We don't have to write it, so the y will be constant. Okay, yeah, like that. Okay, done with um, the first derivative of x, and then we have to type again, and then we have to type again dou z per dou y equal, when we have when we want to solve the derivative of y, so the x will be constant, we type again x with 2 power, and then the power in y is 3, right? Is 3. We type 3 in here, and then y 3 minus 1 is 2. Okay, done. So the partial derivatives of z equal x2 and y3 is 2xy3 and 3x2y2.